All right, guys, welcome back. We're going to be doing our quotient rule now. Okay, and again, just like the product rule, don't be deceived. It would be lovely if we had a quotient and we were trying to take the derivative of it, and we just took the derivative of the top and divided it by the derivative of the bottom. That would be grand, but unfortunately, that's not the case. So it's a little bit more complicated than that. And rather than do another mini proof, I'm just going to state what that is. So the derivative for two differential functions, of course they have to be differential, right? All right, f of x divided by g of x is equal to the following. And in this case, the order of the terms matter. It didn't matter for the product rule because we were doing addition, but the quotient rule uses subtraction. So the order is important. The order matters. And we start with the bottom function and take the derivative of the top first. So you take the derivative of the top first, and then you subtract the opposite. So numerator times the derivative of the denominator. All right, so again, this is one to memorize, and the order is important this time. All right, and then we divide it by the denominator squared. So it's a big formula to memorize. There you go. And again, some people like to use the prime notation instead of the Leibniz notation. So if it makes it a little bit messy or a little less messy, more tidy, then use that. Okay. So there we go. Let's put this formula to use. Let's try an example. So we would want to differentiate. So that would be the instructions. Could be differentiate, find df dx, find f prime. Lots of different ways of saying the same instructions. And our function is this: x squared divided by 1 plus e to the x. Okay, so our thought process. We want to find the derivative, and we're looking at this, and we see a quotient. And there's nothing we can simplify, right? We can't perform any division. We can't separate our fraction. So we're stuck with this quotient. So that's triggering us to use the quotient rule. So the top is going to be our f, and the bottom, the denominator, is going to be our g. Okay, and we have our rule right here. I always recommend writing out the rule as many times as you want. Oh, I'm using the same functions. Let's make this simple. Let's call this h. And then that way we can stick with our function for our formula. Okay, so it's going to be bottom function times the derivative of the top minus top minus the times the derivative of the bottom divided by the bottom squared. Okay, so let's hop to it. So bottom function, 1 plus e to the x times the derivative of the top minus top function times the derivative of the bottom all over the bottom squared. Oof, that looks kind of ugly, right? But we can do it. I'll switch colors to help us keep track of everything. Okay, so we have 1 plus e to the x. What's the derivative of x squared? Good. All right, and then what's the derivative of 1 plus e to the x? See, derivative of 1 is 0. Derivative of e to the x is e to the x. Okay, and then we're going to divide that by 1 plus e to the x squared. All right, so that's using our rule. Our next step would be to just kind of clean up everything. So let's distribute that 2x in that first term. All right, we can take a step back, see if we can factor anything out, anything like that. All right, and then I don't really see anything that we could factor out. Maybe if anything, we could factor out an x if you want. Sometimes your textbook, the answers in the back of the book, it will do things like that, just kind of play around with the final version, which is fine. Again, I'm okay as long as you apply the rule and do some basic simplification. But when you guys are doing your homework, you know, just keep that in mind. Sometimes they just put it in a crazy simplified form. But I'd be fine with this expression or this expression. I think either one's acceptable. Okay. And then that's that. So why don't you guys try an example on your own? So you guys are going to find a derivative of f with respect to x if f of x equals 1 plus 2x over 3 minus 4x. So go ahead and push pause and work out your solution and then come back and we'll talk about it. Okay, so according to our rule, we do the bottom function times the derivative of the top, derivative of 1 plus 2x, let's see, 0 plus 2, okay? And then minus the top function times the derivative of the bottom, so 0 minus 4, so write negative 4, and then we'll put that all over the bottom squared. Okay, so we apply our rule. Now I like you guys to clean it up. So let's distribute the 2, and then we can distribute, oh, let's be a little clever here so we don't get too confused. We have minus minus, right? We're gonna distribute a negative sign. So that's really like distributing a positive 4. So that's a lot easier than subtracting and distributing a negative 4. So let's distribute that positive 4. And then we have the 3 minus 4x all squared coming along for the ride. Don't leave that at the gas station. Okay, what can we do? Love it when things cancel. It's like my favorite. 10 in the top, 3 minus 4x all squared. Can we do anything else to simplify? No, I think this is good. We don't have to multiply that out or anything. All right, there you go. So now we can take the derivatives of a function we can take the derivatives of a constant. We can take the derivative of a sum, the derivative of a difference, the derivative when there is a c in front, and we can take the derivative of products and quotients, and the derivative of e to the x. So we have a whole bunch of tools in our toolkit right now to find the derivative.